Okay, so let's get started. So let me get the screen down. Figure out how to do that. So this is circuits, and this is an example of some fall from a circuit. Hopefully get this into your notes really fast. No. So hopefully you're all, whoa. Okay, you all have to get used to one of my favorite pastimes, which is disposing of markers expeditiously. Ooh, that didn't work out well. Okay, so hopefully you're here for CS 365, and I'm Brad Vander Zanden. In the back, our handsome person who's going to stand up to take a bow. We have Ryan Ethan, who is our teaching assistant for this class. And together, we'll be bringing this edition of CS365 to you. Before I go through the roster, I actually wanted to. So today, we're basically just going through some general informational things and getting into a little bit of material. So basically, this course is intended as a survey of different programming language concepts and systems. It's primarily about programming languages, and there's two basic things we're trying to do in this course. First, we're trying to teach you Java. This is the only required course in the CS curriculum that is about Java. Okay? Second thing is we are exposing you to some alternative programming paradigms. So first of all, we're going to talk more extensively about object-oriented programming than you've probably gotten in your other classes. Okay, so you probably have not gotten a huge amount of inheritance. I'm guessing, I'll just take how many of you in 302 did a lot with superclasses, subclasses, inheritance hierarchies? Anyone else? 302? Wow, was this under me?
Well,
5 years ago.
It wasn't required.
Okay.
It was just something I did.
Right, okay. So a lot of you don't yet have a lot of experience with object-oriented programming, real object-oriented programming. That will change because Java is a completely object-oriented language. We're also going to be going into something called event programming, which is a fancy name for graphical user interfaces. Okay, but it's a different way of programming because your program is responding to events like from the mouse, from a tablet, from a keyboard, rather than from textual input that's typed in, say, via CN or scanf or some other means from the console. So it's a very different way of programming. We'll be doing graphical interfaces for a few weeks. We will be doing concurrent programming, and I understand that in 360 you also do concurrent programming using, I think, pthreads, correct?
Yeah.
But pthreads is a library. Okay, there's also threads that are part of languages. So threads are part of the Java language. They're built in. So we'll be going over Java's threads and Java concurrent programming. Another paradigm that we'll be going over is something called functional programming, okay, where the emphasis is on writing functions and not having what we call side effects. So when you assign, the traditional way of programming is that we are modifying state information. Okay, we have variables like A, B, C. We're assigning values to them. We're changing their values. True functional programming is write once, read only. You only change or you initialize a value to some or variable to some value, and then you never change it thereafter. And all computation is done using functions. So a classic example of that would be factorial. Okay, you would write, I'll just do pseudocode. So you might have def fact n. Okay, you say if n equals 0 or n equals 1, return 1, else return n times fact of n minus 1. Okay, and I know I'm not doing any error checking to see if n is less than 0, but notice there's no variable assignment here. Okay, we have a variable n, but we only read from it. So functional programming is yet another way of thinking about programming. There's multiple functional languages. There's Lisp, there's Scheme, there's Haskell, there's ML. In this class, we'll probably be using Scheme because it's one that I'm familiar with. It turns out, believe it or not, that functional programming is probably the most widely used programming paradigm in the world, and in fact is the most widely used by non-programmers. Okay? You probably would never guess unless I told you what that functional language is. Spreadsheets. Turns out spreadsheets are based on functional programming because you write equations, right? A1 equals B1 plus C1. You change C1 and that immediately executes a whole bunch of formulas that depend on that affected cell. What are those formulas? They're essentially functions. So basically changing one cell causes a whole bunch of functions to be evaluated, which then are reflected in cell updates. So actually spreadsheets are a form of functional programming. So those are the major paradigms that we're going to be going over this semester. And we're also going to, kind of as a subtopic, be going into detail about programming language constructs that have probably been alluded to in other courses but not really examined in great detail. So for example, inheritance, you probably have seen some inheritance but haven't rigorously studied it. Exception handling, most of you probably have not seen real exception handling. Your idea of how to handle an error is to either return -1 from a function or to use set jump, long jump. But there actually are exception handling mechanisms built into most modern languages, including C++. We'll be covering that. Module mechanisms. Again, C++ has a pretty crummy module mechanism. Java has a very strong module mechanism that allows you to combine several related pieces of code into one package that can share their implementation. Okay, so we will be covering these different generic templates is another thing. You've probably used templates. I doubt that anyone's ever told you how to write a template. Okay, so in this course, you will learn how to actually write templates as opposed to just using templates. So part of this course is about going into programming constructs in more detail than you've seen before, you may not have even seen. And in doing so, while we'll be typically using Java as the preeminent example because that's what we're learning, I'll also be comparing and contrasting that often with C++ because C++ also has many of these mechanisms, and quite honestly, you need to know how to use these mechanisms in C++ as well. Okay, but predominantly you will be programming in Java rather than C++ in this course. And then later on, you'll be doing some programming in a functional language as well. It is possible that we will cover scripting languages, but I have not decided yet. That will probably be based more on time than anything else. And I teach a scripting language course in the fall. It's actually half databases, half scripting languages, 465. So oftentimes I leave the scripting languages to that course. So, questions about what we'll be covering in the course?
We do anything with JavaFX by any chance?
No.
Swing?
Yes. So when we get to graphical user interfaces, we'll be in Swing. But unfortunately, there's a whole bunch of Java things we won't get to. FX is one. There's servlets is another. That just don't have time. If we had a second course, that's when we'd get into a lot of the Java frameworks.
I was just wondering about FX. It's still kind of new.
Mm-hmm. I understand. And I don't know it, so other than by name. Actually, that wouldn't stop me from lecturing about it. Okay. So, next thing I want to do is go through some general information about the course where you can find lecture notes, example code, homework exams, blah, blah, blah. Okay, so the website, hopefully you can see it. Can you all read it even in the back of the room, or you all need glasses? My vision went from 2015, my first quarter. I was on a quarter system, to 2100 in 10 weeks. So at the beginning of the semester or quarter, I could read the Blackboard perfectly, and by the end of the quarter, I was squinting at it. I was an adolescent, so that, and my vision is now worse than 2400. So, however, correct it. I'm pleased to say that for the first time in December, I read the 2010 line on the eye chart, so I'm pretty pleased about that. Okay, but at any rate, it is web.eecs.udk.edu/BVZ/CS365, and if you're looking for class information, then it is going to be there, or it is going to be on Blackboard, so the homework assignments will be posted on Blackboard, and you will be submitting through Blackboard. And I haven't set it up yet, but there will be, and it will be appearing as a link. There will be a Piazza site for this course. I believe all of you have used Piazza at this point. Is there anyone who has not? Excellent. So it's just a good discussion forum, and I prefer that you send email or post questions to Piazza rather than sending them to either me or to Raihan. And the reason is that if you start sending questions to me and Raihan, we may answer them differently. And then it gets into a mess when we start grading. If you post it to Piazza, then we're all on the same page. Plus, I don't have to answer the same question 5 times. Okay, it gets answered once. Also, sometimes one of you will step in and answer the question. That is greatly appreciated. In fact, at the end of the semester, when I'm thinking about whether to boost people up, your participation on Piazza and in class is one of the big reasons why you get boosted up. So if you see something on Piazza and you think you can answer it, go right ahead. Sometimes I might say, no, that's not right. Please don't let that faze you. So at any rate, if you have questions, please post them on Piazza. Like I said, I will be posting a link probably later today that you can use to sign up. And I will be making my announcements via Piazza. So initially I will make a couple announcements via Blackboard, but after that my announcements will be on Piazza. So you need to monitor Piazza. There are ways to post anonymously to Piazza if you don't want your identity to be revealed to your classmates. So if you're a little gun shy, there is anonymous ways to post. Okay, and I'm not going to go over it because I'm not sure how to do it, but it's possible to do. Okay, so announcements and questions answered on Piazza. Homework assignments post it and submit it via Blackboard. And other information about the course and lecture notes are found on the website. Okay, so general information. Okay, my office is in MinCal 312. My office hours are from 2 to 4 on Wednesdays. We'll tell you in advance that this coming Wednesday I have a talk to attend from 3 to 4 on Wednesday, but typically I am there from 2 to 4. That's always a good time to get me. That's my email address. As I say, I prefer that you typically post stuff to Piazza, so it's more personal stuff that you send me, such as I broke my leg. You have a, you're looking, Ryan, you just kind of had a, sorry, I ski, so that always comes to mind as a ever-present thing. If you have grading questions, you would send them directly to Raihan, but otherwise, I'd rather that you post to Piazza, and we'll get up office hours for Raihan in a few days as well. Here's a big one, and I'll explain it in a little while, but I'm making class attendance mandatory and will be taking attendance. I'm giving you 3 classes that you can skip, because I know stuff comes up. You have conferences to attend, you get the flu, you need to be somewhere, a tire goes flat, so you can miss up to 3 classes. After that, you're going to lose 5 cumulative points or half a letter grade. And here's the reason I'm doing it. I am going to be experimenting with a flipped classroom this semester. So I'm going to have you watch videotaped lectures before class, and in class you're going to be doing your homework assignments. Okay? That may seem like an unusual thing to do. Why can't I do my homework by myself? Okay, I'm going to give you an analogy. If you're learning to golf, how well do you think you learn to golf if I demonstrate how to swing a golf club and then you go off and do it by yourself? Okay? I know for a fact because I golf. You learn bad habits because you don't have someone sitting there looking at you as you do your swing. The way you typically learn the piano or a musical instrument or golf or how to ride a bike is someone is there watching you and correcting your mistakes. Okay? I know that's the opposite of how we do it in typically in classes where we lecture and you sit here and listen to me for 75 minutes. And guess how soon it takes for your eyes to glaze over? Does anyone know what the average attention span is of an adult?
20 minutes.
20 minutes. Good, Nick. May not even be 20 anymore. Those studies were done before the advent of the internet and before the advent of personal devices. I would wager that your attention spans are significantly less than 20 minutes. So even if I was very entertaining, I understand that Dr. Plank is very entertaining, but I'm not as entertaining as Dr. Plank. Not most people aren't. Holding your attention for 75 minutes is not easy. And even if I can hold your attention for 75 minutes, it's unlikely that you're actually really learning for 75 minutes. So it turns out that lecturing is the least efficient way for you to learn. Okay? And flipped classrooms, it looks like increasingly from educational evidence, are the most efficient way for you to learn because you learn by doing, not by passively listening. Okay? If you tried to learn how to ride a bike, I could sit here and demonstrate for you until the cows come home how to ride a bike. And I can pretty much guarantee that when you left here, you would think, wow, that looks easy. And you would go out, and what do you think the first thing would happen when you got on that bike and tried to ride it? Probably flat on your face, right? Well, maybe not flat on your face, but you're almost certainly tipping over. Okay? So the thing is, you learn by doing. And the problem is, when you go off and do homework by yourself, you tend to get off track. Okay? I know because I can see homework scores from past years, 60%, 70%. You get some feedback from the TA, but let's face it, there's about 45 to 50 of you Ryan has a limited amount of time. He has better things to do with his time than spend 40 hours a week on this class giving you detailed feedback. So, I believe that the best way to do this is to have you watch video lectures before class, or you can read my notes. I really don't care. Some of you learn better by reading notes or reading the book. Some of you do better with watching someone talk. Then when you come here, there will occasionally be lectures in class like today, but for the most part you'll come and you'll be working on your homework. This doesn't work if you miss class, okay? And I know that if I make it optional, most of you will figure you have better things to do with your time and you will start your homework the day before. This way you will start your homework well before it's due. Well, I'm actually not sure if we have to talk about this. At least I will be circulating around class. If Ryan is available, he will be too. And we'll be helping you out with problems, getting you over the hump. So hopefully rather than spending 2 hours stuck not knowing what to do, you can spend a couple minutes and then we can figure out what the issue is. Yes?
So is the length of the homework assignments designed that you actually get it done in class, or just...
No, I don't think it's that. You're just going to get started. But at least getting started is often, 50% or more of the issue. You won't know how to get started. Yes?
Are we allowed to sort of work together in class and stuff?
Yes, I was going to get to that. So another thing is you are going to be allowed to work together in class. Okay, so that's going to help me out, and hopefully it's going to help you out. Okay, so because with 45 to 50 students, 2 of us can't really get to, you're all going to have problems now and then. It's going to be hard to get to everyone, but if you can help out each other, that will also be good. So we are going to be experimenting with it. I have to admit this is the first time I've tried it at the upper level, so we will see how it works. I will say that when I've tried it in CS 102, that my letter grades have improved by 2/3 of a letter grade over the course of 3 semesters. So it really does seem that having basically people in here, basically our biggest value added is being able to lend you our expertise about stuff that is troubling you in class. Having you sit and listen, like I say, for 75 minutes is not the best use of my time or your time. Also, with the videotapes, I will say that they will total often 30 to 60 minutes, but they're broken down in chunks like 10 minutes, 20 minutes. If you get bored, you can go off and do something else and come back to it. Okay, and you don't have to listen to it all in one go. So we are going to give you, or we're going to give that a try, but as I say, that's why it's important that you be here for class. And again, you will probably not finish the homework in class because they probably will take more than 2.5 hours. And programming, does anyone know what the range of speed is on programmers? Roughly speaking, between the fastest and the slowest? It's about 100 to 1. So some of you are just much faster programmers than others. For those of you who are wondering who is 100 times faster, think Dr. Planck. Okay? He's amazing. Okay? When I have done his courses, he will say, this should take you like 2 or 3 hours. It took me 15 minutes. And then it takes me, say, an hour and a half, and it took him 15 minutes. And I'm not that slow. But I know immediately when I see that people aren't finishing it in 2.5 hours. It's just, that's how fast Dr. Planck is. He thinks that, people are maybe 10 times slower than him. He does not understand how fast he can sling code. So, he is truly amazing. Okay, so just telling you that too. If you're feeling bad in his courses when he estimates that it should take you 2 hours and it takes you 4, it's because he doesn't realize how fast he is. Okay, and if you really can do it in 2, you're doing pretty good. Okay, textbooks. Programming language pragmatics, yes, I believe there are a few homework assignments out of this textbook. There are reading assignments from it, so I do require it. I do not recommend that you buy a Java book. Okay? There is fantastic online resources for Java. If you just have to have a desk reference, I suggest something written by Herbert Schilt. Seems like some people don't like him. I think he writes the most accessible books of anyone I've seen. So I don't know where he is edition-wise, but either of those is good. However, quite frankly, the Java tutorial site is, in my opinion, amazing. Okay, so it has different things. They call them trails for getting started, learning the Java language, and I would use their tutorials. I have in my lecture notes pointers to tutorials for the days that I'm covering that material. Also, you will find that Java, unlike C++, has so much that it is very difficult to keep it all in your head. So I suggest that you bookmark the Java API site, because there you will find all the Java classes listed, and for each class, let's see what's a good one. Let's find the linked list. There we go, linked list. You will find what its superclasses are. You will find a brief description of it, although oftentimes they'll point you to the tutorial if there's more to be said about it, but it gives you a basic overview of that class, tells you when it was introduced. So this one was introduced in version 1.2 of Java, gives you related classes that you might want to consider. Sometimes there's alternatives, so rather than using a linked list, you might want to use an array list. Gives you a succinct description of the constructors, and then if you click, it will take you to a longer description of that function, followed by the methods provided by that class. And again, by clicking on them, it takes you to a more detailed description. Okay, if you don't know, for example, what E is, this happens to be a generic. It's a type parameter, but you could click on it and it would tell you more about that. So, I think between the tutorial and the API, you have ample online resources to understand what is, or to find information you need. So I really don't think you need to rush out and buy a Java reference text. Okay. Also, StackOverflow.com. How many of you have used Stack Overflow? So a bunch. Yep. StackOverflow.com is a good place to find answers to questions you may have about Java. So, as I said, you either need to get a copy of the Michael Scott book, or when I assign problems from it, you need to be able to get your hands on someone else's copy. Or this has happened in other courses I've taught. People have generously scanned it in and posted it to Piazza. Okay, sorry, I'm not going to do that, but often someone has done that. So you can ask and post something to Piazza, ask someone to post it for you. Okay, something else. I know it's not going to be popular, but it is what it is. I need to make sure that you do actually look at the videotapes or read the textbook or my notes before you come to class. So, beginning of class, there will be in-class quizzes on Blackboard. There'll be multiple choice or multiple answer or maybe numeric answer. I don't expect them to be hard. It's not like you have to study for these things, okay? But you need to view the lectures before you come to class. Otherwise, it's going to be a big waste of time in here as you try to paw through material, figuring out what to do. I need you coming prepared to class, so I need to incentivize you. Okay? As I said, I don't expect you to study for these things. Okay? They're going to be easy multiple choice. They're not going to be open note, however. And the reason is I got feedback on this from a previous course where I had open note quizzes, and people said, yep, I didn't bother to watch your lectures. I just pawed through the notes and answered your questions. That didn't work out too well. So you need to bring your laptops or your tablets with you to class. Also, you will be programming on those laptops, so you need to bring them with you. So homework assignments will be 30% of your grade. There's one midterm, March 11th. That's right before Tuesday, March 11th, and the final worth 25%. And they will be closed note, but you'll get one page that you can bring in front and back that you can scribble anything that you wish. Okay, I'll make sure that you have whatever Java stuff you need. My exams are not heavy on coding. Okay, that's what the homework assignments are for. Coming up with code on exam is a high stress thing. A lot of you have difficulty doing it. So, and I can ask, toy questions that everyone can answer, or I can ask something beefy and half of you will answer and half of you will feel like crap when you walk out. So usually my stuff is more like fill in the blank, multiple choice, essay questions. So that is the way it goes. Also, because you can skip up to 3 classes, your 3 lowest quizzes will be dropped. Also, if this is going to be a real undue burden on you, please let me know. We might be able to work something out. But if you break a leg, I don't expect you to be in here. If you have the flu, don't come. Okay? We don't need to share that way. Okay. So, already talked about what we're covering in the class, and one other thing, we will have some implementation issues, so we'll probably go over how some of the garbage collection schemes that can be used. We'll go over how virtual methods get implemented. You probably have not seen how stuff like that is done in your other courses, so we'll get into that too. I will say that this is not your typical course on covering programming languages. So I kind of pick and choose from the Michael Scott book. The Michael Scott book is organized in a very traditional way. They go over parameter passing. They go over different ways to call functions. They go over different loops. Really, that puts everyone to sleep these days. Puts me to sleep. I cannot lecture on it without myself feeling sleepy. So by now you know what are the basic loops, right? For loop, ooh, yeah. While loop, indeed. And then, more recently, for each loops that iterate over arrays, okay? Oh, and there's do while loops, okay? What more can we really say about them? Well, it turns out the book finds a lot to say, but I can't say it's interesting, okay? We can also study history. We can study people's past mistakes. But I found that's not terribly interesting too. So parameter passing, there's 2 basic techniques. There's call by value and there's call by reference. There's also some hideous thing called call by name. It was used in the 80s. It was a disaster. No one uses it anymore. Okay, we could study that so that you won't make that same mistake. Guess what? I bet none of you ever devises a language other than a tiny language. Certainly, you're unlikely to be devising parameter passing languages. So, telling you about past flameouts in programming languages might be a nice historical history lesson, isn't very relevant. So the book enjoys talking about some of those historical flameouts. Feel free to read them. They will not be assigned. Okay. So here's the basic deal. Back in the 80s and 90s, when CS was really evolving, there was still a lot of ferment about how programming languages should be designed, and a lot of ideas were tried. Okay? We have a pretty good idea in 2014 about what works and what doesn't work, although it's interesting. My research area is graphical user interfaces and human factors, and it actually is interesting how ignorant about cognitive psychology program designers are. And language designers always would pass stuff off as, oh, that's syntactic sugar, okay? And they were morons. They knew nothing about cognitive psychology. Study after study has shown how their stupid decisions with respect to programming language design has led to decreased programmer productivity over the years. Here's a good example. Okay, while loops. Okay, while loops, you may not think about it anymore, but while loops for their condition, what is natural? It turns out natural is to say, I want this loop to terminate when I've accomplished some goal. Okay, that turns out to be when I tell you to do something, okay, it's typically do it until you get this goal. Do it until you find this person's name. How are while loops written? Negatively. The way you write while loop conditions is you keep doing it until while some negative condition is satisfied. Okay? That's not the way we talk in the real world. Okay? Well, it turns out when you try to teach this to 102 students, they really struggle with it because they're used to saying do until, not do while not. Okay? Well, that was an idiotic decision by programming language designers who didn't understand anything about cognitive psychology. And yes, I have strong opinions sometimes that you'll get to hear about. So, at any rate, over the years, slowly, they have actually started to realize that programming sugar counts, and actually scripting languages now take a lot of that into account. Okay, so we won't be probably getting to scripting languages. You can see there what the language paradigms are. But it turns out programming language design is important. It's just you're not going to be doing it. Okay? In the 80s and 90s, it turned out a lot of people did do programming language design. Plus, in the 80s and 90s, there was such experimentation going on and no dominant language. There were several dominant languages. You had to know about 5 different ways to pass parameters. You had to know about dynamic versus static scoping because you were likely to run into both types. These days, everyone realizes that dynamic scoping, and we will actually cover it briefly, is a horrible idea. And static scoping wins. So it really doesn't pay to spend a lot of time on it because it's just not in languages. We will go over dynamic scoping because a couple commonly used languages like Perl made the mistake of using dynamic scoping, so we have to talk about it. But at any rate, 80s and 90s, you needed to know a lot of the stuff that's in parts of the Michael Scott book. People were experimenting with different forms of loops. That's great. They no longer are. Okay, there's some clear winners. So we cover more these things like object-oriented programming, event-based programming, functional programming, concurrent programming, the big overarching things, plus stuff you haven't seen before, exceptions, modules, generics. Okay, questions about that? Outstanding. Okay, so lecture notes. They are all set up. They're not set up by day, but the thing shows the number of lectures I intend to devote to them. And if you're coming here, you should have a pretty good idea what is what, but I'll also be coming up with the video. So I'll be adding something here that is video lectures and what you should be viewing. And I will add dates for that so that you know what you're supposed to be viewing on that date. So my notes tend to be summaries of things. I don't go into tremendous detail, but I do hit the important points. Here's another one, Java Basics. I like outline form a lot, so you'll see a lot of my notes organized in outline form. So I kind of like to give you the cliff notes. You can then look at the tutorials to get more information. Okay, and I also give you textbook readings. Typically, you can scan through this stuff in the textbook if you read it at all. Okay, my Blackboard quizzes are going to be from my notes and my online lectures. They're not going to be from the textbook readings. The textbook readings help some of you understand stuff better, but the big thing is my notes and what I say in those lectures. Yes.
About how long are those lecture videos?
They're going to vary from 5 minutes to 20 minutes, but you're going to get several of them. So they're normally going to be about 30 to 60 minutes. Okay. So I will say a big complaint I got when I tried it once before in another class is I feel like I have to do 2 lectures, one before and one in. That's why you're doing homework in, because you're getting payback for seeing the lecture beforehand. We're just changing what you do. Okay. So at any rate, my notes, and then when you have issues with writing code, a big thing is being able to see examples. So I have my own examples. Obviously, you can get examples online as well. Most of these I will go through also using an online lecture so that you can see what's going on. Okay. As I said, homework be on Blackboard anywhere from 1 to 2 weeks. Sometimes they're 1 week assignments, sometimes they're 1.5. I will have something posted by Tuesday for you to be working on in class on Tuesday. Went over exams. Plagiarism policy. Seems like this always comes up. I don't like it. I've decided to at least make sure that you have read it. Next time in class, I'm going to hand it out on Tuesday and at least make you sign it and date it so that you can not claim that you have not seen the plagiarism policy, because that's always the first line of defense when I call in a couple students and say, your assignments are identical. I didn't know that wasn't allowed. I didn't see your plagiarism policy. Well, I'm sick and tired of hearing that excuse, so I'm printing it out and making you sign it. Okay, here's the highlights. Okay, I'm letting you work in class on the homework assignments, okay? But there may be some problems that I say you can't work on together. So if it's an essay question, chances are I'm going to tell you you can't work on it together. If it's a programming problem, chances are you can. Okay? So I don't want to see identical essay answers. Okay? The other thing is, if I tell you to work independently on a problem for some reason, don't give your code to someone. I consider that cheating just as much as accepting the code from someone. And thirdly, don't go to some place like Cramster.org and expect them to do your homework for them. Here's one bad thing about Cramster.org. They do really nice homework solutions. They're slick. They go above and beyond the call of duty. This raises enormous red flags. So, in 102 a couple semesters ago, I had a bowling lab. Someone posted it on Cramster.org. And it was a beautiful solution. Did all kinds of great graphical output. Oh, that's right, I never asked for graphical output. The TA was like, what's this? And then, goodness gracious, 4 people submitted that solution. So it didn't work out too well. There were F's all around. It wasn't a happy scene. So please, let's not go through that exercise, okay? But on Tuesday, I'll print it out, make you sign it. Sorry, I know it's a bit trite, but that way I don't have to hear about how you haven't seen the plagiarism policy in the course. Okay. And finally, this is from 2007, but actually the Java language has not evolved. The basic mistakes you make now are the same as the ones that were made when this guy, Ben-Ari, created it in 2007. This is a great source of answers to problems that you may have, especially as you start using Java with interpreting its compile and runtime errors. So it's a great place to look before you spend a lot. You can also definitely go to stackoverflow.com and do Google searches, but also this really is a nice document for like what happened, what is the meaning of the no class def found error, which every single one of you will see at some point. Okay, it can be confusing when you first see it. So this is a good thing. And you're saying, wow, 2007 is so yesterday? Yeah, well, all that Java's done in the last 10 years is add stuff like FX or different frameworks, or it's tinkered at the edges. It has not fundamentally changed the base language in 10 years. Okay, I think the last major changes, as far as I'm concerned, occurred in version 1.5. In fact, most of the major changes were over by 1.4. And right now, I think we're up to 1.8, but we're running 1.7 here at the university.
I can't remember if they were adding Lambda functions in 1.8.
They may be adding, or there's, I forget, something is rumored for 1.9. So if they're either going in 1.8 or 1.9.
I'm really looking forward to those.
So you'll like functional languages. I will say, you'll either love or hate functional languages. Okay. But actually, a lot of the good stuff from functional languages are already showing up in programming languages. So garbage collection was a big thing in functional languages, and they found their way into conventional languages. Lambda forms are finding their way in, which was a big thing. Okay. So questions about any of this? Yes. Nick?
Do you have a preferred IDE that we use for the class?
Yeah, it's called VI. Seriously, you can use any IDE you want. Seriously, I do use Emacs and VI, but Eclipse, I think, is the one we have on the machines here.
And
NetBeans is good, right? So, I think that when I've used stuff, I use NetBeans. So I'm fine with you using an IDE. Okay, but you have to learn it. Okay, and if you go to the lecture notes and you go to Sysit, yeah, if you go to the Hello World application, it actually walks you through how to do it in NetBeans. So. Obviously, so I guess that's the other reason to use NetBeans. It's because it's Sun's and now Oracle's preferred vehicle. Okay, now, when you submit stuff, we will have instructions on how to submit it. It has to run on the university's, actually, we'll have to figure this out. It's going to have to run using a version of 1.7. So, we will tell you how to bundle them up. Often you'll bundle them up using something called jar files, which we will get to next time. Okay. Other questions I saw? Yes, Tommy?
Yeah, so are you going to deliver the videos with iTunes U like you did last
yes.
time? Okay.
Mm-hmm. So, how many of you just use Linux exclusively? You do, Tommy?
But
okay.
I have access to
okay. If it absolutely cannot get access to iTunes U, let me know, and I will start uploading them to Blackboard. Okay. Same thing. If you can't get access to iTunes U, let me know. It's okay. I can upload them to Blackboard. It's just ungodly slow. Okay. Other questions? Fantastic. So. Rest of today, just going to give you a quick overview of the main differences between Java and C++ because they're a bunch. And I know I said I wasn't going to give much on history, but I will give you a quick overview of the history of Java, like the 2-minute thumbnail. So, here's what happened. Does anyone know what Java was designed for originally?
Set-top boxes?
Set-top TV boxes. They were 15 years ahead of their time. Eventually, we did get set-top boxes, but in the early 90s, a group at Sun decided the next big thing in set-top or next big thing in computers was set-top TV boxes. Little early with that. Okay, DVRs is what they had in mind. They were off by about 15 years. Oops. So, to their credit, very fast pivot. The World Wide Web makes its debut around, 93, 94, makes a big splash. They immediately realized, hey, we could make it work with the World Wide Web. And they repackaged it. I forget what its original name was. Anyone remember? I don't think it was Poke.
Oak.
Yes, I think it was Oak. And they renamed it to something catchy, Java. And it caught on very quickly. For one thing, you could use it to easily download things called applets, which were small programs, to your computer. And at the time, the internet was ungodly slow, like 128K slow. And Java was different than C++. C++ has a monolithic executable. If that's 5 meg, it means you have to download all 5 meg before your program runs. Java, by contrast, dynamically loads classes. So as soon as the first class is downloaded, it can start executing. And then it downloads other classes and loads them in the background. So over very slow modems, this was highly desirable. Secondly, Java set it up so that when it ran on your computer, it was in a sandbox, and it could not get access to things like your protected memory, because what did Java do? Does anyone know what Java did fundamentally that stopped people from breaking into the operating system? What?
Virtual machine?
Yeah, well, the virtual machine, but there's some feature of C++ that is incredibly security, has holes in it that people exploit. Yes,
They didn't let you have access to pointers?
very good. Java nixed pointers. So that is the biggest source of hack attacks in C and C++, is because people forget to do things like they read from the console, and they allocate a buffer 100 characters long. What hackers discover? Ooh, if we give them 1,000 characters or longer, we could overflow the buffer and get into parts of memory maybe we shouldn't, or do things, alter their programs to do things they shouldn't. And Java nixed that by not giving you access to their pointers. They're there, you just can't access them. So that was the sandbox, and so Java could do things on your personal computer and you were safe. Plus, Java did not give people access to your file system unless you granted permission. That's the other big thing, is you don't really want someone snooping through your files, trying to find out what your passwords are, what your bank account number is, cool stuff like that. So those were the two big things that made it safe to download Java. And then it had the dynamic loading that made it well suited for slow modems. So it quickly caught on. There was a second thing that really Java hit, and that was the rise of object-oriented programming. So it turned out that C++ was too difficult for business programmers. It turned out engineers could learn C++, but business programmers had trouble with Java. It looked like Smalltalk finally had its day. After suffering for 20 years and being the originator of object-oriented programming, Smalltalk was starting to be adopted by businesses because business programmers could learn to use Smalltalk. And then Java came along and it put the nail in the coffin of Smalltalk, essentially. Okay, because it turned out that business programmers also could learn Java and use it effectively. And, the World Wide Web was big. businesses were programming for the web, they adopted Java. So that was the other big thing that propelled Java into the limelight. The fact that it was easier than C++, and so it could be used not just for applet and internet programming, but became widely used for regular application programming too.
So
Yes.
with Smalltalk, is that like a programming language?
Yes. So, sorry, I'm laughing because it dates me. So Smalltalk was the first, not the first object-oriented language. Simula was the first object language. Simula was developed in the early to middle 60s for doing simulations. Then a person named Alan Kay with Xerox PARC liked Simula, had an idea for a PC computer, and developed Smalltalk as the language that would be used to program PC computers, late 60s, early 70s. Sells Xerox PARC on the idea. They start to try to develop a personal computer. Turns out Xerox PARC is not a computer company. They are a Xerox company. They botch it. Okay? So Smalltalk becomes a cult following with object-oriented programming, but never caught on in the mainstream. But it didn't die. Okay, so mid-70s, Steve Jobs takes a tour of Xerox labs, sees this technology, thinks it's great, and doesn't adopt Smalltalk, but adopts the small personal computer side of things, graphical user interfaces. Culminates with the advent of the Mac in '84. Okay, this is great. Steve Jobs was always pissed off at Microsoft for ripping off his interfaces, pissed off at Google for ripping off his interfaces. Whoops, that's right. Steve Jobs ripped off Xerox PARC. Minor details, okay? So there you have it. So he hired Alan Kay away from... So Alan Kay is the big name. He developed Smalltalk. He was the one who essentially developed the guts of Apple. Essentially, you can thank Steve Jobs for recognizing the technology. You can thank Alan Kay for actually developing and implementing that technology. Okay. Steve Jobs was fantastic at recognizing great design and then getting it implemented. Okay. He actually was not a great programmer, but he was amazing at spotting good ideas and making them work. Okay. So at any rate, Smalltalk had this cult following, and people really liked it. They thought it was purer than C++. Okay, C++ was jury-rigged onto C, basically because Bjorn Stroustrup, who developed C++, knew that in order to get it developed, the best way to do it was to strap his fortunes to the most popular language of the day, which was C. So C++ is a bit of an abomination in the eyes of language purists. Whereas Smalltalk was beautiful, it was elegant. By the way, I hated it. So happy it died. But that's neither here nor there. For some reason, I did not get it. A lot of language purists did. They loved it. Early 90s, object-oriented programming finally catching on. C++ is popular, but business programmers can't learn it. So Smalltalk finally has its day. Java, bam! Takes that little mouse that was peeping out of the thing, thinking he was going to be in the limelight, pretty much does away with it. So you still find Smalltalk here and there, but it never got out of the box, so to speak. So at any rate, that's why Java is so popular today. Plus, Sun had a good marketing machine. So all those things make Java what it is today, which is one of the three most popular languages. I think that actually more code may still be written in C or C++ than Java. May be wrong about that, but it's one of the top three. So you need to know it. Okay, Java is stripped down C++. Java is developed about 15 years after C++, so they corrected a lot of mistakes that C++ made. Whether pointers was one of those mistakes or not, you can debate, okay, endlessly. There are some people that believe that pointers are God's gift to mankind, or at least Ken Thompson's gift to mankind, because he was the developer of C. Donald Knuth falls in that category. Okay, he said when he saw pointers, he was like, "This is it." Okay, because you could create all kind of linked structures. Other people, especially compiler writers, thought this is the apocalypse. Okay, this is the devil incarnate come to undo all of our efforts from the last 20 years. There is still raging controversy. It's a religious war as to whether you like pointers or not. C# decided they had to actually put some of the functionality of pointers back into the language. So C# falls somewhere between C and Java in pointers. But at any rate, Java developers said pointers evil. So pointers actually still there, just you can't directly get access to pointers. So that's one big difference. So let's actually say, what did they do differently? Thought I had already brought that notebook up. Oh, this is slow. We have software coming up. It'll be up in a moment. Maybe. What is wrong?
I think it's opening behind Firefox.
Maybe. Yes, you look like you were right about that. Oh, no. Well, no, we still have Firefox in the foreground. Okay, let's quit Firefox. Huh. Okay, there is another way around that problem. It's called PowerPoint, and it is called the new slide with nothing on it. That's not going to work well either. Maybe Fire...
Under layout, you could just make a very blank one.
Yeah, well, actually what I was going to do is go into Firefox, and I think I can say blank. Nope, that used to be the case. Gosh darn it. Ah, that's it. Thank you. There we go. Okay. So, differences between C++ or between Java and C++. So, big differences. So, please read my notes because I have the big differences, but all the differences, but no explicit pointers. So, they still have pointers under the covers, which you'll see in the online lectures. Okay, another big difference is no monolithic object file. So they load class, you'll see, classes dynamically, which leads to faster loading and startup. Okay? Okay. Another big thing, no explicit, you have garbage collection, we'll call it that way. So in C++, you have to explicitly deallocate memory. In Java, it's done automatically for you via garbage collection, which is a huge reduction in errors because it is very common in C++ to reclaim storage before you've actually eliminated all the pointers to it. And then you get nasty seg faults and bus errors because you gave the memory back to Malik. Malik hands it out to someone else. Now you have an old pointer. It goes into that memory and you core dump. Java, you still allocate off the heap using new, but you don't explicitly deallocate. That's done for you. Okay. Another big difference is that Java, strictly speaking, used to be interpreted. Now I'm going to put this in quotes because many modern day Javas are not interpreted. They're running off compiled code. But we'll talk. So interpreted via a virtual machine. So C code runs natively on whatever machine architecture it's executing on. By contrast, with Java, you invoke a so-called virtual machine which interprets Java instructions. So when you compile Java, it compiles into something called bytecodes, which is essentially Java assembly language. Bytecodes look a lot like assembly language. And the Java virtual machine interprets these bytecodes. So initial versions of Java, much slower than C, up to 10 times slower. Obviously not acceptable. So over the years, the compiler folks have developed different compilation strategies for Java. So sometimes, just as you invoke the virtual machine, it will compile the bytecodes down into object code. Other times they'll use, anyone familiar with just-in-time compilers? I've heard the concept. So just-in-time compilers, actually that is a just-in-time compiler, I'm sorry. Just-in-time compiler is what it's called. Compiles bytecodes into object code. When VM, so you hear me refer to the Java VM as virtual machine, so when it's invoked. See, what I want to know is, have any of you heard of hotspot compilers? Yes, no, anyone? Okay. I think if I actually type Java, you'll see it. See it? Java hotspot trademark? That's because Sun was the first one to actually develop what are called hotspot compilers, but it's actually a generic term. What it does, takes interpreted code. There's a performance monitor constantly analyzing the code. It figures out what parts of your code are being constantly executed, like for loops, for example. It will, after a couple, when it realizes that this is a hot spot in your program, something that's really being constantly hit, it will compile that piece of the code and insert it. It will actually code patch your program. It will replace the interpreted code with a pointer to a jump to the compiled code. Okay, that's object code. So most of your program is still interpreted, but the hotspots are compiled. Anyone know why that is better than just-in-time compilation? Faster, right? Why compile, say, an entire class when only say 5% of it is used extensively? 95% of it's used 1 or 2 times. A lot of it's error handling code that's never executed. Why compile it? So the advantage of hotspot compilers is they only expend compilation time on the important parts of your code. So it appears faster to you. When you use just-in-time compilation, that's going to cause a brief delay when you start up your program the first time. So actually you'll see it as we go through the semester. You'll see sometimes I'll type Java in a program and it'll take like 5 to 10 seconds before it starts executing. That's because it may be doing some compilation before it does it. So hotspot compilers run interpreted code but compile hotspots and patch in the compiled code. Okay, so just-in-time compilers, they compile bytecodes into object code when the VM is invoked. Hotspot compilers differently. They're dynamic compilers. They actually compile your code as your program is running. They do it in the background. Okay, and then they temporarily stop your program, patch it, and then start it up again. Okay, even so, Java programs still run more slowly than C++. Does anyone know why, even with these compilers, Java programs still run more slowly? It's another feature of the differences between Java and C++. Yes.
Optimization?
So one is optimization. So you know why? I mean, I can presumably use some optimization techniques with bytecodes.
Because C++, all of it is bytecode, so it can better optimize.
Exactly. So C++ is able to look at the entire program, and so it can do inter-module and inter-function compilation. So it can figure out, maybe I should inline this function, because bytecodes don't. I'll show you. Basically, bytecodes are for a single class. So you can only do what are called local optimizations. You can't do global optimizations. So that's one reason it's slower. So actually, let's go to the next. Got this all down? This is such a hack.
Uh-oh.
Oh, give me a break. Okay. Got it all down because I'm erasing. We'll get that notebook software fixed. I'm not exactly sure what's
I think it
wrong.
might be opening in like the very background for some reason, like behind everything else.
Okay, we'll give it a try because this is. It doesn't look like it's working, but it could be opening in the background behind everything else.
Yeah, the little light indicators now.
Yeah, the thing doesn't say.
Yeah. So it's really gone out to lunch on me.
You could try to launch it with Spotlight. Sometimes that works.
Right. The thing is, yesterday when I was doing something, I remember the update thing saying something about Notebook, and I blew it off. And perhaps I shouldn't have. So I'm first going to investigate that, Tommy, before I do anything else. Okay, so Java slower than C++, even with what's called just-in-time compilation. Okay, reason one is that Java JIT compilers can only optimize one class at a time. You'll see that Java compiles into what are called class files, so each class compiles into a different class file, can only optimize one class file, whereas C++ compilers see the whole program.
Is there any more use for that now that we don't really have slow modems? Just in time? Because
Yeah, because there's still a slight delay. If the thing is 5 megabytes, it can still be a little bit of a delay. It's not a huge issue anymore, I will admit. But you still see it. When you see loading, you see like sometimes images spinning. It's kind of a similar idea that it's different, but it still makes a difference sometimes.
It's used in Android. Like if you have a big application, it doesn't need to load up all the classes.
Okay, there's a good. Okay, so it's the difference between local here and versus global optimization. Global optimization gets you some additional wins. Okay, can someone tell me another reason why Java is slower? Don't tell me it's interpreted. I'm saying even with just-in-time compilation. Okay, yes.
Is it because, actually, no.
Is it?
Well, go
Is
ahead.
it because C++ programmers are generally trying to make their programs run quicker
They are through some, but there's a
through pointers?
not through pointers because C++ is using. I'm sorry, Java's using pointers too.
Okay.
Yes.
Does the lack of access to pointers somehow inhibit passing by reference and function calls?
No. So you're all on the wrong. It's good tries, but they're all done. So Java has a lot more runtime checking. So C++ is like a race car. You take off every protective mechanism. No airbags. They weigh more. No spare tire. They do. So a race car, you do take away no seatbelt, maybe. You take away all the safety features. It runs faster. Java has a lot of runtime checking. So runtime checking, which you can't eliminate.
So like they probably crash a lot less than C++.
No, they actually crash gracefully. So for example, here's an example of a runtime check. You can't go past the end of an array in Java. If you have an invalid array subscript, it will catch it, throw an exception, which you can either catch or the program, you'll see when we get into it, will simply, it won't crash, it won't say segfault, instead it will say exception array subscript out of bounds. So it's a graceful crash as opposed to an ungraceful crash, a safe. And it does a lot of this runtime checking. And then the third one is it uses garbage collection. So maybe that goes a little bit back to pointers, which is that instead of using explicit memory collection, it's using implicit memory collection. It's doing it for you, and so it's a little bit slower. Okay, so just quickly, because we've hit a bunch of them already. There's just
Like a clear screen button.
be nice. Actually, there is. I should have used it. Thank you. Okay. Very good. Okay. So let's see. There's three other main big differences, and we'll get into. So first of all is Java has modules. C++ doesn't. So that is they're called packages in Java. C++ has something called friends and namespaces, which are a piece of garbage and don't really help a whole lot with project management. So that allows you to put several related classes together. Second big thing is Java has no multiple inheritance. So it uses single inheritance, which is actually a rather big change. Third big thing is that everything in Java is a class. Okay, no function can appear outside a class. No function can appear outside a class. So even main appears inside of a class.
Outside of class.
Whoops, thank you. Sorry, just like your things, mine's are on lunch, mine's on lunch, can appear outside. So even main is going to appear. So those are the three other major changes. Okay, so read this is the differences between C++ and Java in my lecture notes, because there are a few other differences. And I will post a Piazza link this afternoon. You need to get to that. I will also, through Piazza and through Blackboard, tell you where the initial set of videos are that you need to view by Tuesday. Remember, bring your laptops to class.
Oh, really?
One second.